So even this problem statement, like the earlier one, we can actually express the logic using SQL. You can go to the problem statement once again. Here the data is in orders and customers, but it is in local file system. As we have done earlier with the core APIs, here also we have to start with importing the scala.io.source, read the files from local file system into RDD, and then converting to data frames. After converting it into data frame, we have to register these things as temp tables, and we can run the queries. So let's go ahead and do it. Import scala.io.source val orders raw equal to source dot from file data retail underscore db orders hyphen part hyphen 5 zeros. Okay, and then dot get lines, and then I can create RDD of by name orders by saying sc dot parallelize of orders raw. Same is the case with customers. Okay, once we create RDD for both orders and customers, the same way which we have done earlier, we also have to apply dot to list. From here, it will differ a bit. In case of converting, in case of where we want to run the query after converting the data sets into data frames, we can actually create data frames for the fields that are required only for this problem statement, or we can create data frame for the entire table also. It's your call. So in this case, I will just create a data frame for the fields we are looking for. In orders, we just need order customer ID, and in customers, we just need customer ID, customer first name, and customer last name. We don't need anything else. For that reason, I am creating orders data frame. So let me name this as orders RDD and customers RDD. And then I'm creating orders data frame by applying map on orders RDD. And from each order, let me name it as O. Let me get the order customer ID, which is nothing but third field and of type integer. Okay, and then to convert into data frame, I just have to say 2df and give the column name, which is nothing but order customer ID. This is the column name. Same thing with the customers RDD. And if you look at the problem statement, we are looking for only the first name and last name as the final solution, and first name and last name are the second and third fields, and first field is customer ID. Because we have to join orders and customers and customer ID, we have to get this one, and also we need to get the second field and third field. Okay, so I can say C implies C dot split of comma of 0, and we have to keep it as a tuple, and then to int, and also I need to get split comma of 1. And also I need to get c dot split comma of 2. Okay, so this is how you can actually create the map statement, and then we have to convert into data frame with names customer ID, comma customer f name, comma customer l name. Okay, and it is you need to be extremely careful to give correct column names to the correct fields. Once this is done, we can actually create the RDD. Again, to launch the session, I'll be using number of executors as 1 and executor cores also 1 and memory as 2 GB because the data volumes are very low. I have demonstrated as part of the previous video also that orders is only 3 MB and customers is under 1 MB. Okay, for that reason we will launch the session like this. With specific number of executor cores in memory so that we use capacity a bit optimally. As the session is launched, you can see SQL context is available as SQL context. So we can use this one after registering our data frames as temp tables. But before registering those, let us make sure that the code which we have written have no issues. So I'm copying till here and pasting it here. Okay. So far, no problems. Let me run this. It could cause some issues. Let us see. Because I did not specify order ID as a tuple. Yeah, it worked fine. So this data frame has only one field by name order customer ID. And then customers, it should be DF here. Customers DF should have 3 fields. Okay. If you want, you can actually say orders df dot show and see the results in orders, and customers df dot show to see the results in customers table. And now I can actually register these two as temp tables. So orders df dot register temp table orders and customers df dot register temp table customers. Now I can use SQL context dot SQL and then write the query. I just need the customer last name as the first field and customer first name as last field as part of the column statement. And then from customers left outer join orders. Okay. On customer ID from customers equal to order customer ID from orders. And also we only need those records where there are no orders for the given customer. So I have to say where order customer ID is null. Okay, and also data is have to be sorted by customer L name first, order by customer L name, comma customer F name. This is how you can write the query. First, let us see if we can get the results properly, and then I will make the modification to the code to actually save it into the file. I'm just formatting real quick. Okay, now I can copy this one and then paste, and then so there seems to be some issue with the way code is formatted. Okay, I have to put the dot here and then take the show to the next line. Now let us see. So there seems to be a bug in the code. Let us see what there is. Okay, it is trying to read from someone else. Let me check where the problem is. Okay, it seems that it is conflicting with the tables in Hive. So I'm actually giving the table names as orders underscore DG and customers underscore DG. Okay. The problem which I'm facing now is because my cluster is a multi-tenant environment. You should not face this problem in the actual certification exam. If you run into issues like this, okay, where it is giving permission denied issue, you just try to make the table names unique by suffixing with your initials or something. Now let me try. Paste, and then let me run the query. Still there is some issue. Okay, I know what is the problem. I just have to change the names also, names here as well. Now let me paste. Now it is working. Now you can see that data is sorted in ascending order by L name, which is last name, and then in descending order by, sorry, in ascending order by first name. But yeah, so this is correct. But I think still I have to do some additional processing. Let me get this size. Of this data set. Okay, for that I think I can say count. Paste, hit enter. So you can see whenever I run, it is running using many threads, and we can reduce this 200 threads to fewer by adding this additional step in between, which is nothing but SQL context dot set conf. spark.sql.partitions, and let us use 2 or 1. If I want to save as one file finally, it is enough to change it to 1, but you need to careful and decide this number based upon the size you are trying to process. In this case, as our data sets are very small, we can actually use 1. Okay, and then copy and then paste here. I have to put it in the double quotes. So this has to be a string. So that being said, now I can actually convert into RDD the way I have done earlier, and then say map. Okay, and as part of the map, I can say rec.mk string of comma and space, because that is the delimiter which we are interested in, and then I can say dot save as text file and give the path, and the path is again in the problem statement. I am just copying this one and pasting here and changing the string to my user ID. As I have created these files as part of my earlier topic, while demonstrating the solution for the same problem statement with core API, I have to delete this directory. So I'm logging into another session here. And then I'm checking whether I have the file. Yes, there are these files. I'm just previewing the data to see what I have. You can see the data. Now I can remove this fs-rm -R and paste. The directories are deleted. Now I can run this. In the other session where I have run the earlier scripts. Okay, still. Okay, there are 2 dots here. That's why it is causing issue. So let me fix it. I have to delete this dot and put the dot here. Also, I need to delete this and put it here. And also, I need to delete this. And then I can just copy this and paste it here. The reason why it is again running 200 threads is because I haven't ran that command successfully. Okay, so let me do one final thing before we wrap up. Let me remove these files again, and let me run these 2 code snippets just to show you that it will not run with 200 threads once I reset the Spark SQL shuffle partitions to a lower value, which is 1 in this case. Now you see it is very fast, and there is only 1 thread to process and save the data. That being said, to validate, it's pretty straightforward. You just have to say sc.text file and give that location which is used while saving the files. And as there are only 30 records, we can safely use collect here. And then for each, and then println. And we can see the data. Data is in ascending order by last name and then ascending order by first name if the last names match. Okay, and all these four Mary Smiths are four different guys. They are not same. If you want to get only the distinct names, you can use distinct also. But in this case, there are four different Mary Smiths. If you want, you can extract customer ID also to confirm that they are different Mary Smiths by using the customer ID as primary key. By using customer ID, which is primary key. So this is how you can actually write most of the problem statements on which in which data is structured, either by using core APIs or Spark SQL.